In this video, I'm going to show you how to compile and run a C program at the console window. So rather than using an IDE to develop your program, you can actually just write a program in a text file, and I'll show you a make file as well that will allow you um, to develop a C program. Okay, so the first thing, let's go to sigwin.com, and we want to download the compiler. And so the address is just sigwin.com, and we scroll down here to installing Sigwin by running this setup file. So we'll download that. Okay, and let's go to downloads, and we're just going to run this application. And just click on the prompts, install from internet. It's going to place it in this C/Sigwin64 root directory, local package directory, and just click continue clicking next. For download site, you got all these different options. I'm just going to pick the mirror, Sigwin mirror constant. Okay, so for the packages, we need 4 packages. So under package where it says all, I'm going to expand that. I want to go to the development package, and the 4 that I want are GCC core. So GCC core, and I'm going to come over here to a drop-down menu and just click the latest version here. I need the GCC G++. I'll do the same thing there. GDB. I guess I'll do the one before the test here. And then I need the make. And I'll do the latest one here as well. So those are all the 4 that you need, and we'll just hit next and next. And it will download. And I'll pause the video here while it's downloading. Okay, so now the installation is complete, and we want to create icon on desktop. Okay, so that's all there is to it. So let's launch this terminal. All right, so now we have a terminal where we can run commands and execute our program. So the first thing is I want to navigate to the directory, so I'm going to change directory C:, and you can see that the path will appear next to the prompt. And I'm just going to go ahead and navigate to where my files are. Okay, so I have a make file, and I have a source file, a .c file. Those are here. So within this folder, I've got this make file and this source file. Right, so I'm going to look at both of those. So here's the make file, and this is what's going to actually compile and link the source code to form the executable. And here's the actual C program, the source code. So this is just a simple program that computes the voltage and power for several different resistors in just a series circuit. So, all right. So the first thing I want to do is let's go ahead and just type make. So if I type make, you can see right now that all I've got is the make file and then the source file. So if I type make, then it's going to execute these two commands. And now when I do a listing, now I've got an object file and I've got an executable file. And the executable file is the actual program that we want to run. And so you can see that the make command created both an object file and an executable file. And so it on the object file, it's a .o. The executable, even though I don't have the .exe, if you look in the make file, when I create the object file, I specify a .o extension. When I create the executable, I don't actually specify a .exe extension, but it automatically puts it on there. So that's why you see a .exe there. So I'm going to go ahead and run the program by just doing / and the name of the executable. Okay. So let's run the program. Enter the voltage source in volts. So we'll do 15 volts. Resistor R1, let's say, is 820. R2 is 2.6 kiloohms. So entering that in scientific notation, 2.6 times 10 to the third. R3, let's say, is 470. And R4 will be 1.1 K. And it prints out the answer. So total resistance is 4990. The total current is a little over 3 milliamps. And the voltage across each resistor, 2.46, 7.82, 1.41, 3.31. The power in watts, you can see on this row here. This is in watts, so this would be about 7 milliwatts, 23 milliwatts, 4 milliwatts, and 9.9 milliwatts. And then this is a verification of Kirchhoff's voltage law, which shows that all the voltages sum up to be 0. So I don't want to really spend much time, discussing the circuit aspect of the program. This is more just on actually writing a program and compiling and running the program. But you can see that the program actually works. Okay, so if we go back and look at the make file, this is what the make file looks like. And so I've got a couple of symbols here. This CC is going to equal GCC, and C flags is going to equal this right here. GCC is the compiler. This dash wall just means that we enable warnings, and we're using the C11 standard. Now, the way the make file works is you have what's called a target, which you see here in red, and then to the right of the target is what's called a prerequisite. And so the prerequisite is needed for the target. And so there's really, you can see there's not a whole lot going on here. What I have in green are comments. So essentially what it's doing is the object, the .o target needs the actual C source file, and so the command, and you have to do a hard tab here. So when you see on lines 9 and 14, you can't just put spacebar. You need to actually hit the tab key inside when you're creating the file. So this is what's called a hard tab. If you look at the show all characters, you'll see here that you see this arrow is it's a tab, so it's not just spaces. Okay. Okay. And so what it's doing here is it's saying, okay, I need to create this object file, but I need the source file, and this is how I create it. So I'm going to substitute GCC for CC. I'm going to substitute this for C flags. And what the -C is, that's the compile option. So when you do it this way and use the -C, it will take the .c file, and the -O means output it to a .o file. And then on line 8, the executable needs the object file, which was created down here, and this time you don't use the -C. So here you're just taking the object file and compiling it into the executable file. And in your directory, you'll see the .exe extension on this. Okay. And then the only other thing is for clean. What clean does is it just deletes the object and the executable file, because you can create those, or you can recreate those very easily. So if we go back to the terminal, and if I do ls, you can see I've got those 4 files. If I do make clean, it will remove the object and executable file. But if I do make, it'll recreate them. Okay, and so when you're developing code and you're constantly making updates to your source file, you can very quickly remake the object and the executable files. So, I mean, you don't have to have a make file. So if I do make clean, I can get rid of the object and executable files, and I could actually, just type it in like so. Now, in this example, you notice I'm not using the -C option. I'm just going to go ahead and create I'm going to go ahead and do it in one step. So when I do the GCC -wall -standard equals C11, if I take the source code and I don't use the -C compile option, I'm going to go ahead and output it to the executable. And what you'll see now is I've got the executable, but I don't have that object file. Or, alternatively, I could have done like I did, in the make file and done it in 2 steps. So anyway, so you can see that the program still, oops, let's see. Oh, I misnamed the output. So yeah, you can see I accidentally left off when I did the let's see, up here when I specified the output file, I left off the underscore console. But it doesn't matter. It's going to output it to whatever name that you give it. Okay. 15 and what values did we use here? 820, 2.6K. 470, 1.1K. All right, and so it gives us the same answers as before. Um, so that's what I wanted to show in this video, is that you can create your source code in just any text editor, and save it as a .c, and then you can create something called a makefile. Um, but you don't want to save it as a makefile. So if I go to File, Save As, if you're using something like Notepad++, it'll actually give you the option of saving it as like a makefile, a .make or a .mk, but you don't want to do that. You want to save it as you want to save it as all types, and then just use the word makefile. And I'm not going to save this because I've already got the makefile, but when you're creating a makefile, you don't want to save it with the .make extension. You just want makefile with no extension. Okay? And so when you create different programs, the only thing you have to change is just the name of the program. And so you can use your makefile as a template and just do a search and replace. So let's say you created another program called temperature. You would just replace series circuit console with temperature, and then that would update this makefile to work on the temperature file. Say you had a program that converted between different temperatures, like Fahrenheit to Celsius, and so you could update your makefile and just put it in a new directory. So instead of just having a series circuit directory, you could create another directory called temperature and put its corresponding makefile and its source code in there. Okay, that's going to do it for this video. But yeah, this is just how to create and basically compile and link and execute a C program directly at the console, rather than developing your code within an IDE and running it in that environment. So the downside to that, to doing it this way, is debugging is not very easy when you're running a console program, whereas in an IDE you got built-in debugger, and it's more difficult to do it at the console window. So that's the downside. But this is just a quick way that you can run and execute your programs without having to go through the IDE. All right, that will do it for this video.